Hello everybody. This video is to demonstrate how I go about archiving old diskettes on a Windows PC. I know there's other videos out there that do this. This is just yet another one to show, what works for me may work better for you. You have plenty of choices to do something similar. This is how I do it. And another reason why I'm making this video is I'm the kind of person that when I look for videos on how to do something, I like looking at all the different videos, different ways people do it. I may choose one over the other, or I may create a hybrid of them. So this is just my contribution to everybody who wants to archive vintage floppy disks, or even more modern floppy disks. So anyway, a little thing to keep in mind: you may hear noises in the background. This is a very sensitive microphone. You might hear my chair creak. You may hear the dogs walking around on the hardwood floor. You may even hear them barking at whatever might be driving by, which you may also hear too. But anyway, I do videos for content, not actually production quality. So it is what it is. Anyway, so I'm going to start by showing you what my setup is. What I use, I like to use something called a Greaseweazle. And what a Greaseweazle is, this little board here, that connector at the top is a 34-pin standard floppy drive connector. So it gives you a relative idea of the size of the board. The large connector in the lower right is a USB-B, if I recall. Like the printer style USB connection, and then there's other connections for supplying power to some drives, and jumper settings for reprogramming and whatnot. The board I have is very similar to this. It's the version 4 Greaseweazle board. You can still get them. There's a version 7 out there that has additional capabilities, but I haven't really grown into that need myself. So I use a version 4, and the reason why I'm showing you a picture of the version 4 and not the actual device that I have is because I got mine set up in an external 5 1/4 inch device, a box. It's an IBM external box that was used for CD-ROM. But the nice thing about it is I can mount a dual half-height floppy drive that gives me both 5 1/4 and 3.5 inch disk capabilities. And at the same time, the device provides power supply to supply the drive itself. The Greaseweazle gets its power from the USB connection. So, I'm just going to set up a known disk here, because some of the stuff I want to go over is to show you how you might be able to identify an unknown disk. So I'll have that queued up, ready to go. And the next thing I'm going to do is show you the software that I use. And let's see. Nope. Still figuring out where I'm at for my video stuff. There we go. I have all my scenes all set up here in OBS, and I forget what's where. So anyway, so this is one of my many desktops. This is the one that's actually driving my Greaseweazle setup. I want to show you the software first. The software is actually really simple. It can all fit in a folder. There's other files here too, but really the program that you want to get if you get the Greaseweazle device is the gw.exe. Now you can get that from let's see, where are we at here? You can get that from the Greaseweazle GitHub website, github.com/keyref/Greaseweazle, or you can search for Greaseweazle. The guy who creates this is very, very intelligent, very smart. He does a great job with it, and he's very friendly to the community. All this is open source. It's written in Python, but it's launched under a executable wrapper written, I think, in C. But anyway, so to download it is really simple. You download the files following the links here, and you just extract the zip file into a folder somewhere. It doesn't require an actual real installation to install stuff this place and that. you can just create a folder, or just take it out and put it into a folder called Greaseweazle, and work from there. Now, Greaseweazle is a command line application, and the commands aren't hard to use, but they can get cumbersome after a while. So something else I like to use that is also easy to install is something called a Greaseweazle GUI. And this is produced by somebody else, and it creates a nice, pretty front end. Here's some example screens and stuff like that. And to install this, you just put this file right into the same folder as your Greaseweazle executable, and it does all the rest. And I actually have these here. Like, here's the Greaseweazle GUI. Now, there are more than one GUI out there. This, I think, was one of the first ones, and I use it because it just works for me. There's, probably other ones, and you can search for this at Greaseweazle GUI, or search for Greaseweazle GUI, or it's at DesertSageSolutions.com/Greaseweazle GUI. But this is a front end that basically it builds the command line for you and then launches it in a command prompt. So it's not a direct read off of the Greaseweazle hardware, but it gives you some front end capabilities in case you don't know how to build the command line, because depending on certain floppies, you may have to tell Greaseweazle to skip every track because it's a 40-track disc and not an 80-track disc, or you may have to change the disc speed because it was done on a very old piece of hardware. That the disc was from a very old piece of computing hardware, so before certain standards have been applied. But anyway, so what I'm going to do here is I have this set up for info and setup. I always run this every time I fire this up to make sure it can talk to my Greaseweazle. So I select what I want to do, and then I hit the select button, and this is the command it's going to send, gw.exe info, and I'll hit launch. And if it detects the Greaseweazle device, it'll show it right here, and it did detect a device. Now, one thing I need to do is I need to turn on my drive here, because until I power up the drive, I'm not going to talk to anything. Now, this will create some whining noise. It's got a loud fan, but I need to turn that on before I do anything. So, getting back to that, we'll see this in operation. I'll kind of composite the images here, and let's see. Again, I'm trying to find my way around my desktop here, so we don't need that, and we don't need that. Oh yeah, that's right, I wanted to show you that. So you can see where the gw.exe is in the Greaseweazle folder, just a folder I put into my documents folder, and the Greaseweazle GUI stuff can go right in there. And then you just create your own shortcuts for the desktop or the taskbar. So anyway, so it's running now, and I'll hit back. And now I'm going to do another function. I'm going to read from a disk. So I click read, and I'm going to set all this up without any of the default settings. So this disk here says 0 disk. I mean, I can look up online what it is, but this is just for demonstration purposes. I'm going to make an assumption that this is going to be this may not work right either. I just realized something. Yeah, I don't know if you heard that squeaking. That squeaking might mean that this is a bad disk, and I don't want to ruin the heads of my drive. That disk may have been stored improperly. So let's try this disk instead. This is an actual unknown disk, and I heard that squeaking too. Alright, we'll give it a shot here. I don't like the squeakiness. If it starts squeaking a lot when I read it, I'm going to eject the disk and try to find another disk to work with. But anyway, so reading disks. With the Greaseweazle GUI, I can create, I'm just going to call it test. And I'm going to create the disk type. There's many different flux image disk types that you can use and Greaseweazle supports an awful lot, including Commodore-based ones, but of course you have to have a Commodore drive, like GCR. I think some of the Apple ones. Many of the popular emulator formats are listed here. I like to use one called SCP, stands for SuperCard Pro. SuperCard Pro is actually a piece of hardware, I don't think you can get it anymore, that did something similar to a Greaseweazle, but you know, the person who created it more for working on Commodore disks than anything else, but it will read regular flux. Just Greaseweazle came out shortly after I got SuperCard Pro, so I found the Greaseweazle. I found it more versatile. But I always like the SCP format. It's well documented. So I'm going to choose that as the disk type. This is what it's going to save my image as. Then I'm going to select the folder. And from here, I'm just going to use this PC, Drive D, and I have an emulation folder. I'll put it in there. So you can see here it's building the command line, gw.exe, read, and then this is the file it's going to create. Now I'm going to cross my fingers here. This is all I need to do right now. I can leave everything off, and it's going to work with certain standards. It's going to assume 80 tracks, and it's going to assume double-sided. So for a 5 1/4 inch disc, that would be 1.2 megabyte. And when I start the read process, it'll launch a GUI. It'll launch a command prompt and give you the standard Greaseweazle output as it tries to read the disk, and it will save that flux image to this location. So I'll hit launch. Remember, I said I heard a little squeaking in the drive, thinking that might be a bad disk, so I may stop this right away if it continues to squeak. Okay, so far so good. It's working. You can see it's reading raw. It's called raw flux. So basically, it's just reading the magnetic flux at a high, I think it's 25 nanosecond intervals. It reads the magnetic flux. But you see track 0, side 0, track 0, side 1, track 1, side 0, and it's working all the way through. It's going to go to track 80. Actually, it might go to track 82. I think it'll move the head as far as it can go. And some of the stuff I like to look for is roughly the same size flux lengths and the same duration in flux read times. If I see any weird amounts, it may be a bad section on the disk, or it may be an unexpected format. So anyway, this will keep going. You know what I'm doing wrong here? You know why I didn't hear the squeak? Because this is actually reading from my A drive, which is the top drive. You can see the green light is on that one. This will read, but the problem is my A drive is, it's got a bad head. This is one of these Epson, I forget the prefix of it, Epson something something dash 800, I believe. It's very nice because it has both drives in a single half height format, but the surface mount capacitors go bad, and I have to almost tear the whole drive down to fix them, and I didn't feel like doing that. And most of my archiving stuff has been going on with 5 1/4 inch instead of 3.5. So I forgot to change one parameter in the Greaseweazle GUI to tell it to use the other drive, but hey, we'll let this one finish. You know, it's almost finished anyway, and then I can actually use this as a demonstration to show you, you know, maybe you have bad hardware. So anyway, that's done here, and you always have to close the command thing before you do anything else. The Greaseweazle GUI does not know how to do that. So that aside, I'm going to do the next one here. I'm going to call it test 1. Oh, let's try it this way. And I'm going to set drive select here. If I click that, then I can use the letters A, B, 0, 1, or 2 to set the drive. A and B work for the most part, but I like using the drive numbers. So drive 0 would be, in this case, the A drive, drive 1 will be the B drive. And as you can see here, it's modifying the command line to include or reference drive 1. Now when I click launch, this is where I'm expecting to hear a lot of squeaking, and like I said, I'm going to cancel it quickly if it does. So I'll hit launch, and no squeaking, so good. So this is going to read, in fact it says it's reading tracks 0 through 81, heads 0, 1, and revs equals 3. It's actually reading each track 3 times. And it'll read it raw for 3 times. Greaseweazle, unless there's aspects of the software, because the developer, Keir Fraser, keeps adding new stuff all the time. He's really active in the updates of his software. It's reading the flux 3 times, but it's up to the end user and whatever program they use to actually look at the flux and decode the flux to determine if they want to use the 3 copies to determine if there's errors, or if there's some, if they can merge them together to make it, look good. But 3 reads, sometimes maybe just dust gets a little bit in there, which we don't want, but it might be on the first read but not the next 2 reads, so it'll give you basically 3 copies of everything. I can change that to 1 on an override, but it defaults to 3. And it doesn't, it'll nearly triple the size of the flux file, but the flux file is in megabytes, not gigabytes. Maybe 10 to 20 megabytes, which seems weird because the floppy drive itself may hold 360K or 1.2 megabytes, but we're basically digitizing flux changes at I think 25 nanosecond interval, so we can create a lot of data just by digitizing the analog flux per track and per sector. Okay, so we got a good read here, and it was nice and quiet, so that made me feel good. Because another thing about backing up old floppy drives like this is if they were stored improperly, yeah, you're going to have some problems. Let me get back to the screen and show you things I can do with this now. All right, so I have 2 SCP files, flux images. Now, at this point here, I can just go put the next disk in and update this number. Or this nice thing about this Greaseweazle GUI is you can actually use these arrows here and watch where it says in file name where it says test 1. Each time I click this, it'll create an increment number, and I can even start at a certain suffix. So whatever suffix I put in goes 2 dashes and then that suffix number, and then I can just manually increase those for each one and make it a quick process of archiving stuff. But I'm not archiving a whole series of these at once. And notice when I finally get down to 0, its suffix goes away and it goes back to this. I think this INC++, if I check that, it'll automatically increase for each run of each time I launch it. But I haven't really played around with it, and I haven't had that need for it. So anyway, I read a disk using the Greaseweazle hardware, the Greaseweazle command line, which is controlled by this Greaseweazle GUI. So another program I like to use is called HXC Floppy Emulator. And yeah, just write that down. I can go to I think I can go to the web page, or I can click the About button, and you may hear the music in the background. The person who created this has kind of I think it's kind of a sense of humor, because it looks like, I'll show it here. It has kind of an animated About screen. I don't know if you can hear that, because that's coming from another speaker somewhere. But doesn't this remind you of a Psygnosis game, Shadow of the Beast? But anyway, and then from here I can go to the website, but I'm not going to do that right now. But this program is a separate thing. You heard of a Gotek drive. Well, there's also called an HXC Floppy Emulator drive, which will let you load disk images and put it onto the HXC floppy emulator hardware. So it's its own thing, and then I think it came out before GoTech. But this has some neat features to let you see your flux images that you created. For example, I'll hit load, and I'm in my Drive D emulation, and there's my test and test 1. I'm going to open up test 1 first. Okay, you see how this is 43 megabytes. So I opened up test 1, and some of the things I look for when I load is how fast it loads. See how it goes a little bit, then pauses, goes a little bit and pauses. Okay, that tells me it's having problems reading some of the flux, or there was flux that was attempted to be read, but nothing was there. And you'll see what I mean here shortly. And this is all part of the process of trying to diagnose what type of disk it is, starting with the highest capacity first, and then working your way down to the lower capacities. So when this is all done, and yeah, it's going to take time here. If it was a clean read of a perfect type of disk, it would have probably loaded almost instantly. So okay, so I have it loaded. So I'll click on, this is the tool that I like to use in here, Track Analyzer. See all this green here? That's from the white space here to the white space here. This is one track. And the green is the sectors. In fact, if you look over here in this area, this is, you can see the individual sectors, their content. All right, here's one that has value in it. Now, I'm still working my way around. It seems like every time I move my mouse off this, I lose that content. I found out if I hover over it and don't have a quirky mouse, and I quickly move up out of the way, then I can go over here and scroll. Okay, so this tells me something about this sector. Okay, it's on track 0, sector 6. Here's a menu, EXE. Okay, so EXE files, menu CGA, menu HRC. Okay, so this tells me it may be an IBM type disk. Could have been K-Pro, it could have been Osborne or whatever. But now I'm looking at the decoded flux. This program decodes flux. And I have the following track analysis formats on. It's decoding it as MFM, FM, or Amiga MFM format. In fact, it tells you up here, is it on the top side or down here? Okay, ISO, IBM, MFM encoding. So it's a standard MFM, which is most IBM 5¼ inch discs. But another view of the, this may not mean nothing. I'm just doing this just to get a quick visual. I can get really detailed into this. Like all these little gray dots and stuff like that actually shows where a flux change is occurring. I don't get into that stuff much myself. What I like to do in this tool is I choose dummy disk, and this shows me the layout of the disk. So these are all the tracks, all 80 tracks, top side, all 80 tracks, bottom side, or however 0 and 1 is. Okay, this is high 0 is 1. But here's what I wanted to show you. You can see every other track is red. Ideally, you should not see any red. Red shows that there was an error reading something. So I read this as an 80 track disc. So if you think about it, every other track is bad. This, I read it as an 80 track disc, but this is not an 80 track disc. It's probably a 40 track disc. So, and I was reading it as a, the high density 80 track. Let's now reread this disc with a different setting. And I'll go back here, close this. I can leave this open. Now I'm going to go and set this as a 40 track. And the way I do that is I now have to, since this drive, and that's another point, this drive can read 80 tracks. If I hook my Greaseweazle up to a 40 track 360K drive, we'll call it, then I won't need this option because the drive itself will only do 40 tracks. But since this one does 80 tracks and it has to read what we believe is a 40 track disc to get a clean read, I will have to do something called turning on double step. And what this does, you set the number of track steps each time it reads, how many times it moves. So basically I'm setting it to 2. That's double step. I can set it to 3 and it'll go every 3 tracks, which means if we read it, the first one will look good, the next one will look bad, the next one look good, because we're skipping 3 tracks at a time. But we just want to read every other track. So we turn on double step with a setting of 2, and it still assumes 80 tracks. So it's going, if I left this like this, it's going to move double step for 40 tracks, and then it's going to be at the 80th track, and it's just, the head's going to be stuck at the end. So we also have to tell it how many cylinders or tracks are here. So 0 to 39 is the equivalent of a 40 track disc. So the Greaseweazle GUI puts this in by default. So since I believe this is a 360K IBM disc that I first read as a 1.2 meg disc, I now have to go in and set double step to 2 and cylinder set 0 to 39, and then everything else remaining the same. See how it builds this command line? You know, you can do this, you can type this in yourself if you know what it is, but these front end GUIs really make it easy. And I'll hit launch. And I don't know if you can hear it moving, but I can hear it. The head's moving a little noisier. It's because it's actually moving 2 tracks at a time. So we'll wait this out till it gets to track 39, head 1. And this is overwriting our old test1.scp. Now, if that actually, if that first one actually had green on side 0 but all red on side 1, that's an indication it was a single-sided disc. And you might find that with things like K-Pro discs or TRS-80 discs. And I've done a bunch of TRS-80 discs just recently, and that's why I wanted to do this video, because I thought, all right, I kind of got it figured out, so I'm just going to share that information. All right, so we have the 40 tracks done up. I'll go back here to HXC floppy emulator, load. Notice the file size is smaller now that I'm not reading 80 tracks of flux or nothing. Open this up. See how it's loading faster and cleaner, because now it doesn't have bad tracks that it's trying to figure out. Hit track analyzer, and there's our clean read. Yes, and you can hover over these. If you look on the right hand side as I hover here, oh, there's one. This is IBM 2.0. Maybe it's a bootable disk. And this is just the tracks, you know, for track 0, sector 1, sector 2, sector 3, and you work your way around. This is almost visually how it's laid out on the disk. These red parts here I don't think are much of an issue. I think they're just sync marks or something like that. But I like to see all green. This tells me I have a pretty good read. If I had some discs where I might see a sector that showed up red, or a sector that showed up gray. I don't know what gray meant, but if the disc has bad spots, you will see discoloration literally in any of these areas where the bad spots are. But this is a visual representation. If you could see the magnetic flux with your eyes on the disc, this is a representation of what it looks like, because we are reading the flux. It's just being converted and coded and turned into colors, so it's easy to reference. So yeah, and this is the other side. So sometimes I'll go through, and a lot of these, you see the characters there are just gibberish. It's probably because it's code data or encoded data. That's an empty track. I guess that's why it's got the slightly darker green color. So I just like to muddle through these just to get an idea what might be on the disk. But some things that you can see is like, I'm not getting it from this. So this, I don't know what it is because it had no label on it. I'd have to hope I find file names that give me a better clue. Well, okay, I can go from dummy disk to track view, and that's where I was finding stuff. Where did I go with that? Yeah, anyhow. I mean, I can learn to dig deeper into this stuff, but really what I want to get out of it is after I image the flux, I load up HXC floppy emulator just to see if it was a good read. So now I have what I believe to be, okay, this even says here 40 tracks, side 1, 40 tracks. So what can I do with this? Well, I have it archived. So if I don't have anything I can use this with, at least I have it copied and backed up. Because Greaseweazle will let you take this, and you know, I could probably show that. Yeah, I'm going to show that. Let's extend this video a little bit, okay? We'll go back to... I don't know. I hate Windows 10. The fact that you just hover over certain areas of the screen and it pops up this informational. Yeah, I don't need to know all that news. Anyway, so I have a blank disk here. Oh, another thing I forgot to show you. And sometimes these things don't work, or they pop off. I'm going to go ahead and close this for now. The other way to tell what type of disc it may be, especially for 5 1/4, you can tell high density from double density on 3 1/2 because the high density ones have the second hole. You can see on this one, this was the double density. This is actually an Amiga disc. Double density doesn't have a second hole right there, and so I'm going to put that back in. Eject this. I've noticed that 360K discs have that center hub ring. See that white ring there? And it's not always white, but it has the ring. See, this is a double-sided double density. It has a ring, but it's in black. And that's a visual indication that you probably have a double density disc if you can't see a label that says so. So I'm going to put this disc in here. I want to cross my fingers the whole process works, because I now have a disk image, right? I have it backed up. For all intents and purposes, it's backed up for whatever I want to use it for. Let's just say in the future I want to create a new disk from that disk image. Well, that I can do. For that, I can hit the back button here, and I can do write to disk. Select. Brings up a whole different set of things. I want to tell it to erase, the tracks. I want to do a double step. Although it can figure out what it needs to do, I like to literally express what I want it to do. So cylinder sets 0 through 39. Right? And I'm not changing heads. The only way you want to change headsets is if you only want to write on one side or the other. And the disk type is SCP. And I want to select the file, which is in my Greaseweazle folder. Oh no, it's in my drive D. Sorry, get through. I got so many files here. Drive D, emulation, test 1. Okay, so I'm going to take that image I just created and make another disk out of it. So I'm going to erase empty. I'm going to double step, because I know it's a 40 track file on a 80 track drive. I don't need this on if I was writing it out on a 40 track drive. It was SCP, so it builds this gw.exe write erase empty tracks step 2 cylinders 0 through 39, and then this is the file name I'm going to write to the disk. So I'll hit launch, and now it's writing everything. And what is a write flux disk is write protected? Really? Oh, you know what? You know why it's write protected? Because I forgot to put the drive 1 in. Some of you may have caught that. I was trying to write to the 3.5 inch disc. Anyway, so we'll launch it again, and this time it shouldn't have a problem. it writes faster because it doesn't have to write it 3 times. Like when it defaults to reading it, it reads it 3 times. So it's going to write a lot faster. Let this go through here. Okay, it says no tracks verified, reason verify unavailable. I don't know why it says that. I think only certain formats, flux file formats, include verify. As I said before, I like the SCP format. I've actually worked with it quite a bit, and it's well documented. The other ones I wouldn't say aren't well documented, just it's one of those things. I've worked with SCP so far, and it was easy for me, so I'm keeping it that way. So now I have a disk that's written. So how do I know it wrote properly? This might seem like a redundant action, but I'm going to try now to read this disk in as flux. I mean, if I had the computer to put it in front of me, I could just stick the disk in and it should work. I mean, I've done this before. I'm just showing you how I do it. So, but for testing purposes here, I'm going to go ahead and read from this disk. So I go back to read from disk and select that option. And this one I'm going to call test. Did I do test 2? Oh, okay, I'm going to call it test 3. That way I know. So again, we're set up. We know this is supposed to be a 40-track disk being read from an 80-track drive. So we're double stepping and doing cylinders 0 through 39 or tracks 0 through 39. Once again, make sure that I'm reading the right drive, because there's dual drives in here. And I think that's all I need to set. So I'm going to go ahead and launch this and let it read this disk that I just wrote. Now, theoretically, I should be able to load this up at HXC floppy emulator and get the same visual image as I did before. And if I do, then I know the whole process worked. I know my equipment works. And, and I can keep continuing to work with this. I have a couple thousand floppy disks that I don't know what their content is. So this is busy stuff for me. If I feel bored, I sit down, I'll use that track or that name stepping thing I showed you about for reading one disk after another, and I'll just back a whole bunch of stuff up, and then I'll go into HXC floppy emulator and look at them individually. I don't know if there are other programs out there that can quickly scan a flux image file and tell me what it is. They may exist. I may have not looked deep enough for them. I haven't really had a major need, because the way I back my stuff up is I like to check them personally. But yeah, there is going to be a time where I just want to say, okay, I got all these flux images, scan the folder and tell me what they are. But because I don't know the disk, I have to verify that I'm getting, the proper, that it's a 40-track disk as opposed to an 80-track disk. I got to make sure I'm getting all that right, or I'll have useless data. But you think a program that can scan through that can make that assumption too, or be programmed to make that assumption. Anyway, that aside, I'm done creating my test3.scp, so we'll go back to HXC floppy emulator. There it is. Open it up. Looks like a nice, clean, easy read. And we'll go to track analyzer. Okay, ooh, that doesn't look good. Something either didn't write correctly, or there was no data to write. But you know what I see here? These are in the realm where there was no, had the darker green. This may not be a problem for actual use if this disk was actually used in a real system that's designed for. But this shows, at least by this example, of what happens when it gets a bad read. This is probably a bad read because it had nothing to write. So it just probably threw anything or everything out there. I don't know how Greaseweazle will do that, how the software will do that when it comes to writing things out if there was no data there in the first place. But I consider this successful in a sense, but this is new to me. But it makes sense to me to believe that since these are all empty and there wasn't on the original image, that this disk could still be good for use in actual hardware. Let's see if I can go to track view here, and I'm trying to remember how to. There we go. That's how we scroll through it. All right, so yeah, this. See, I can. This view means little to me. I know that these indicators, I'm really zoomed in. This is all the flux changes. And then this is the resolution between, it's timing. So, so this is a flux change, then there's 1, 2, and then a flux change. Here's a flux change, 1 and a flux change. I know something about that, whether it happens after 2 intervals or 1 interval or whatever, that if it changes after a certain time, it's actually a 1 bit. If it changes in a shorter or longer time, it's a 0 bit. That's how it's stored. That's how flux is stored, and I'm not completely versed in it yet, but I am trying to learn how to do that. So I was just trying to see if I can find tracks that had the band. Oh, here we go. There's track 1. There's where I was trying to find. I had the wrong. No, track 0. That's the one that had. Now we're looking to on the right here as I hover over these. The game is now loading. Please wait. Earn to try it anyway, or press escape to select different format. Okay, so this is most likely a game. I was just hoping I'd find like a file name that would tell me, or content in this that would tell me what kind of game it is, or the game's name, but I'm not finding that, and I forget where I found that. Maybe it's on the opposite side. There's the IBM 2.0. That may be a boot block. It's track 0, sector 0 on the top side. I forget where the okay, there's part of the file. Alright, so anyway, I'm just goofing around here. But now you can see what I do. I go about analyzing an unknown disk, and this will work for the 3.5 inch too. And it should also work for any other device that can connect to a standard Shugart floppy connector. I actually have one of those 3-inch disk drives. Who makes them? Amdek. And I've read flux off those, but they use an odd format, and I haven't been able to get Greaseweazle to basically. Well, no, I can get Greaseweazle to read it. I haven't been able to get HXC floppy emulator to sync to it, so I don't get the. I can see that I read stuff, but I don't see the nice, clean, segmented sectors like this on it. There's stuff I can change or tweak in the program to do it, but I can connect that up to a Shugart drive and read it directly, and at least archive the flux and figure it out later. You know, read it now, deal with it later. But, you know, being able to just take all these unknown disks and have tools that can just image it and let you poke around the contents to get an idea of what it may be is nice to have, especially if you are one to archive things and are just insanely curious on A, why do you have all these floppy disks, and B, what's on them. So that's what it does for me. One other thing, I wonder if I can let me check a moment here. I might actually have a Commodore disk, and I'll show you how those work with this. Okay, I found a Commodore disk. This is one that I actually had created on a Commodore, but it's It's something I had for Power Assembler, but this is Commodore formatted. It's not a flippy disk. The problem with the Greaseweazle setup is working with flippy disks. When you flip a disk, you don't have a second index hole. This is the index hole. The Greaseweazle likes to see that index hole appear every revolution. And they do actually make discs, or they did make discs that actually has a second hole in it. It would be designed to be flippy for other types of systems that had, that required an index hole to do things, like the old TRS-80s did that. But since the Commodore disk drives ignores the index hole, you can do flippies. That's why we notched the other side for some Commodore ones to get double the space. But Greaseweazle stuff, especially on an IBM type drive, need that index hole. You can actually use Greaseweazle without an index setting. You can tell it to skip index, or as you see, let me get back to the screen. As you see here, there's a fake index that you can set up. You can play around with that and maybe get something from it, but the Greaseweazle works best for the top, the standard side of a Commodore disk. But I'm just going to show you how this works and how you can also look at the content in HXC floppy emulator. There are certain drives, Panasonic brand drives and TX brand drives, that you can modify to do a flippy disk in one pass. But you have to modify those drives so it knows, where to position the head to read it, and it also reads it backwards. It reads the flux backwards and then just flips it, just like you would, because it's digitizing. So it can read it and flip it just like you would read audio or record audio and flip it, and it runs backwards, or vice versa. So anyway, so we're going to do, and I'm going to keep the same SCP format. I'm going to do test 4 for now. And again, I know a Commodore disk is 35 tracks. The drives can go out to 40. So I'm going to leave that. I'm going to assume this is a 40 track disk. And because it's 40 track and I'm reading on a high density 80 track drive, I have to double step it. So I can read this as with the same settings. All I did was change the file name. So because when we're reading flux, we're not reading the format of the disk. We're just reading all the flux magnetic changes. So I'll go ahead and launch this. And notice a bit in the flux timings. You see side 0 has smaller flux, side 1 has larger flux. And part of it is the way that the Commodore drive or Commodore disk format is. The Commodore disk format is GCR, not MFM. So it has a different look to it. And we will have to tell HXC floppy emulator that it needs to look at it that way. And it's been forever since I backed up a Commodore 64 disk using Greaseweazle. Things may have changed since the last time I did it. I would use my Zoom floppy device connected to my computer with the real 1571 disk drive to read and archive the Commodore disks, just because I had the equipment to do it. So anyway, we have that all read in, and then we'll go to HXC floppy emulator and open this up. It might have problems reading some of the tracks. This isn't loading smoothly, but it is loading. Okay, go to track analyzer. First things first, it looks a mess. Why? Because we're looking at MFM format. So let's turn those off and go to C64. Alright, here we go. This isn't the cleanest thing, but it will do it. This isn't the best program to look at Commodore 64 disk images, but it does work. Because Commodore images or Commodore disk drives change the sector count after so many tracks. So the certain tracks would have a larger capacity for sectors. Inner tracks have a lesser capacity. But as you can see here, I'm hovered over a sector, and then you can see on the right hand side that looks like some basic code, which I know there is on there. There's some text. Some of these other ones here. Let's see, what is orange? Orange might be a poor read. Now you're seeing all the colors. But anyway, so the HXC floppy emulator for Commodore 64 discs will give you an idea. It just won't be perfect. And if you have some of these odd formats, it will readapt this dummy disc to fit that. I just like the dummy disc view. It gives me a visualization. If I went back to track view, it's a little cleaner. Some tracks might not have decodable information. And I think I just lost. All right. Well, looks like something's locking up, or I scrolled too fast. So anyway, this is probably more information than you expected. I know it's more information than I expected to deliver, but I hope it gives you a sense of another way of archiving your floppies or discovering what you have. That was the whole intent in this video. So leave any comments down below if you have any questions, or just, hey, if you want to give me some information to answer some of the questions I had during the video, that'll be great. Like, are there other programs out there which can analyze disk image formats? Oh yeah, let me hop to one other thing real quick here. This is important. So in HXC floppy emulator, I'm going to go ahead and close this, and I'm going to let the program crash. That's what it was doing. All right, so let me load that up again, and load, and we had a good one with test 1, right? So test 1. Track analyzer, dummy view, or dummy disk. Okay, so that's our clean read. All right. The nice thing about HXC floppy emulator is if you want, let's say this is, well, it'll probably, oh, there's the dogs. I told you about that, right? Hang on. Yeah, the dogs are barking at the Amazon delivery driver. Anyway, if this disk was, if I assume it's an IBM 360K, so it probably works on an XT or something like that. So if I have, say, an IBM PC emulator that I want to run it in, I want to save it into a different format that the emulator can read. A lot of emulators are starting to be able to read disk images or disk formats. HXC floppy emulator will let you export disks in different formats. See all these here? Like, if this is a TI-99 disk that I image, I can use TI-99 DSK file, and that'll work in the V9T9 emulators. I've used the JV3 stuff I was telling you I did the TRS-80 disks, and they can be converted into JV3, and that works with some of the emulators. So this program lets you do conversions to different formats. If I was reading a bunch of Amiga disks, I can save them out. I can take the Flux images, read them in, save them out as ADF files. But Greaseweazle actually is taking care of that to a degree. HXC floppy emulator will also do batch conversions. You can select one format, give it a folder, and it'll convert them all to that format. But Greaseweazle did add the capability of writing directly to certain formats, like, well, not the J, I didn't see the Tandy one wasn't there, so I had to use batch conversion for that to get them to work in an emulator. But here is the ADF format. So if this is an Amiga disk I'm backing up, I can back it up straight to an ADF format, and it'll run directly in an Amiga emulator. So Greaseweazle software does have a lot of capabilities. This GUI front end, Greaseweazle GUI, gives you the ability to manage the operation of Greaseweazle to make it easy and seamless and point and click. So, and here I can also image a Commodore disk right into a D64 file. So it'll do that. I just like to use HXE floppy emulator to get a visual, because discs go bad, you know, and you don't know if it's a good disc. You scan it straight into a format, and then you wonder why it doesn't work. Then you're going back, and then you're running a program like HXE floppy emulator to see what was wrong with the image. And then, but it's a personal preference. But you do have a lot of these tools available to you, and I do use them off and on when I get some downtime, and I can work up, you know, some backup sessions for all these floppies. Eventually I'll get through them all. And any ones that I find, you know, I have the image files, but then, you know, then becomes the issue, how do I extract the data? That comes at a later time, but at least I'm getting them backed up, and for the most part I'm getting them backed up as clean as I can. So anyway, lots and lots of information. Everybody who watches my videos knows they're not short, typically. This one's almost an hour, but I hope it was very informative for you. And again, leave me questions if you have any, and down below, and have fun. If this stuff works out for you, great, awesome. And we'll see you on another video in the future.